Okay, so today we're going to be looking at using inverse trigonometric functions. These functions come in really handy when we want to integrate functions that look a certain way. So this is really important and you need to make sure you take this down. But the inverse trigonometric functions look like this. So if we get the integral of some number, so 1 over square root of some number squared, take x squared. If it looks in the form of this, our answer is going to be equal to arc sine of x over that original number plus our c as per usual. If it looks like this, if it's got a negative in front of it, we're going to get cosine. X on a, same thing. So instead of sine, we get cosine. And if it's got an a on the top and squared on the bottom, and no negative either, it's going to look like this, arc tan. All right, so we'll have a look at how we get these firstly, but then also a couple of examples. Okay, so let's have a look at the derivation of this. So we're first going to consider the differentiation of arc sine x. So if we've got y equals arc sine x, therefore x equals sine of y. Because we know that arc sine and sine are inverse operations, if we take sine to this side, sine to our arc sine, that cancels, leaves us with just x, and sine of the y leaves us with sine y. All right. So if we do that, therefore we have, if we take dx by dy, so we differentiate x with respect to y, we're going to be left with the differentiation, well, if we differentiate sine, it turns into cosine, so cosine y. All right, so cosine of y. Next step, we've got to recognize, just to remind of ourselves, that sine squared x plus cos squared x equals 1. All right, so if we rearrange this, if we get our cosine by itself, we can say that this thing is equal to, move our sine over here and take a square root. This thing equals the square root of 1 minus sine squared of y. All right. So we've had a bit of mucking around so far, but the reason we've done all of this is because now we can say we let our x equal sine y. We can say, like, therefore this equals the square root of 1 minus sine y is x, and this is squared. All right, and that's still for our dx by dy. All right, now we've got to jump also to our another rule we've learned, so the chain rule. So if we've got dy by dx and dx by dy, all right, so by the chain rule, we learned that we could cancel out these ones and we're left with just dy over dy. All right, and we've got the same thing on the numerator and the denominator, so that means it has to equal 1. All right, so what this means, so that's from the chain rule. What this means is we have dy by dx and dx by dy are reciprocals. All right, which might be obvious, but we just proved it using the chain rule. So therefore, we just worked out what our dx by dy is. So dy by dx is equal to the reciprocal of what we just worked out, so 1 over square root of 1 minus x squared. All right. So what we've just done is we've got the differentiation. We've derived it all the way down to this 1 over 1 minus x squared. 1 minus x squared. And so that's the differentiation for this formula for arc sine. All right. We can do the exact same thing, or very similar, for arc cosine and arc tan. I'm not going to show you both of those because it's very similar. Just substitute in, instead of sine, cosine or tan, and we can derive this formula. So just a little note on that. So reversing these processes, we've got down here in red, reversing these processes, we obtain the integral of 1 over the square root of 1 minus x squared. Oh, just lost my square root there. The integral of that to dx is equal to arc sine of x plus c. All right, so we've shown it one way. If we do it the opposite way, we've shown this. So yep, that's our proof. All right, so let's have a look at an example. I think it's going to be a little bit more straightforward when we jump into this. So what we've been asked to do is find the integral from square root of 3 to 1 of 1 over square root 4 take x squared. So the first thing I'm going to do is I'm going to jump back to our original formula. We've got it in the form 1 over something take x squared. All right, so ours just happened to be in the form 1 over 2 squared take x squared. All right, so I'm going to rewrite this as the integral from root 3 to 1 of 1 over square root of 2 squared take x squared dx. All right, now from our formula, we know that the answer straight away is arc sine x over a plus c, but we've been given the conditions. So this equals arc sine x over, our a is 2, from square root of 3 to 1. Oh, that's a 3. So we can now work that out by substituting in our values. So let's get my pen. So what we're going to get is, this is going to be equal to the arc sine of root 3 over 2, subtract arc sine 1 over 2. And if we put this into our calculator or use our unit circle, we know this is equal to pi over 3, subtract pi over 6, which equals pi over 6. Okay, so the formula might have been a little bit tricky to differentiate, but once we get into this form, should be relatively okay for us to be using that one. Okay, thank you.